The last topic we want to cover in this section is called magnetic properties. And what we can say about this is the following. Electrons have charge, and they will always spin. This creates a magnetic field. So when we look at magnetic properties of atoms and elements and molecules and ions, we need to come up with some type of standard. And there's a nomenclature that we use. And the terms that we use to characterize this is diamagnetism, which means that all electrons are paired. There's no net spin, or the spins cancel. And there's paramagnetism, which we have a species that contains unpaired electrons. So there's a net spin involved when we're looking at our atom or our molecule. And one of the things that we can use is something called a Gauss balance. And this is going to measure magnetism. So you kind of set up this particular balance, and we could put a weight on one end and use a ruler to measure how much this is going to be displaced. And on the other end of this balance, we connect a sample or a chamber that houses a sample, whether it be our atom or our compound or whatever we're looking at, and then we induce a magnetic field. So the question is, does this magnetic field repel this species right here? If there's a repulsion involved, this balance is going to move. So the more unpaired electrons, the greater the pull, and the more that this particular mass is going to displace. So we can relate magnetic properties to orbital block diagrams. And we can use the periodic table to help us determine what those orbital block diagrams would look like and how many unpaired electrons a particular atom will possess. And again, we'll come back to this concept in Chapter 9 when we look at molecular orbital diagrams. So these are the things that you need to think about when we're discussing magnetic properties.